All right, so we're graphing here in vertex form. So we always have to start with finding the vertex. The vertex is your middle point, and the entire parabola depends on where that vertex is located. To find the vertex, we're looking for the value of x that makes the base 0. And the reason why we want 0 is because 0 squared is 0. It is the only unique point. So looking here, I'm trying to figure out what value of x will make this expression equal 0. What minus 3 equals 0? That would be 3. So now I just have to do the math. I have to come down here and substitute in 3 and do the math. So y equals 3 minus 3 squared plus 2. Now I do the math. Y equals 3 minus 3 is 0 squared plus 2. 0 squared is 0 plus 2, and 0 plus 2 is 2. If I wanted to write this as an ordered pair, as a coordinate, I'll show what I inputted, which was 3, and what my output was, which was 2. So here we have now found the vertex. I'm going to come over to my table. Notice the vertex is always the middle point because it will always be the minimum or maximum. It will always be located on the axis of symmetry, 3, 2. Now I can come down to my graph and I can actually graph that point. So 0, 0, 1, 2, 3, 1, 2. Here's the vertex of my new parabola. If I was asked for the transformations from the parent function to my new function up here, I could see that my function has moved 3 units to the right and 1 unit up. So that would be an example of a horizontal shift right and a vertical shift up. Now that you found the vertex, we have to fill in the rest of the inputs. Remember, the 3 is the center point. You have to find 2 inputs to the left and 2 inputs to the right. The 2 inputs to the left are less than the vertex, and the 2 inputs to the right are greater than. We're talking about inputs here, which is x. So 3 minus 1 is 2. 3 minus 2 is 1. Notice that it's descending. 3, 2, 1. And on the other side, 3 plus 1 is 4. 3 plus 2 is 5. Notice that it's ascending. 3, 4, 5. A quick way to check your inputs is to count from top to bottom. 1, 2, 3, 4, 5. They should all be in order. So because of the nature of parabolas and the fact that these points are reflections across each other, we only have to substitute in half the table. So I get to choose. Do I want to substitute in 4 and 5, or do I want to substitute in 2 and 1? It doesn't matter, but I'm looking ahead and I see that the base of my power is subtraction. It's minus 3. So if I were to plug in 2 and 1, I would have to deal with negatives. And it just so happens that the majority of mistakes in math happen with negatives. So for that reason, I'm going to be substituting 5 and 4. So in my sketch tool, I'm going to separate this kind of down the middle so that I can keep those 2 sides separate. On the left, I'm going to show the math for substituting in 4, and on the right, the math for substituting in 5. So my function is y equals x minus 3, so that'd be 4 minus 3, squared, don't forget that squared, plus 2. Do the math. Y equals 4 minus 3 is 1 squared plus 2. 1 squared is 1 plus 2. 1 plus 2 is 3. So as an ordered pair, I inputted 4 and my output was 3. Scroll down here so you can see that. So that's just one more solution point. Let's go ahead and input 5. So my function y equals x minus 3 squared, so 5 minus 3 squared plus 2. So 5 minus 3 is 2 squared plus 2. Notice that I'm taking my time to really maintain the structure here. 2 squared is 4. Plus 2, 4 plus 2 is 6. So as an ordered pair, as a coordinate, I inputted 5 and my output was 6. So I can come up to the table now and add those values. So when I inputted 4, my output was 3. Inputted 5, my output was 6. Over here in the graph, I'm just going to graph those 2 points. So 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And actually, I can graph this half of my parabola. Do that again right there and right there. But notice I only have half of a parabola. I need a full parabola. Well, here's the cool part about parabolas. These points on the right are exact reflections of these points on the left. So if I wanted to, I could actually go in and draw my axis of symmetry right down the middle. That would be at x equals 3. And then I can just show that my points are going to be reflected across. So if the output for 4 is at 3, then the output for 2 is also going to be at 3. And if the output for 5 is at 6, then the output for 1 is also going to be at 6. These are reflected. And I can connect the rest of my parabola. So it takes 5 points to graph a parabola. The vertex, 1 to the right, 1 to the left, 2 to the right, 2 to the left. I can also come up here and add that into my table, 3 and 6. Now let's say I wanted to double check my work. I wanted to make sure that my parabola is in the right spot and that these points are correct. I could just pull up a scientific calculator and quickly input 2 and 1 directly into the function to see what happens. So let's start with 2. 2 minus 3, don't forget the squared, plus 2. Look at that, it gives me an output of 3. So I've now confirmed that this output is 3 and this output is 3 as well. Just to triple check, we'll also input 1. 1 minus 3 squared plus 2, and my output is 6. So I am now very positive, very sure, very confident that my quadratic is graphed correctly.